At 13:47 hours in occupied Zaporizhia, 12 Ukrainian drones screamed toward a Russian ammunition train at 97 kilometers per hour. The operators controlling them don't yet know that Russian artillery has already found their position. The first 152mm shell lands 800 meters away, close enough to shake dust from the ceiling. The Russians detected them the moment 48 brushless motors powered up simultaneously. That electromagnetic spike lit up every sensor within 10 kilometers, like turning on stadium lights. The operators have a choice: abort and survive, or continue while under fire. They have roughly 12 minutes to reach the train. The Russian artillery needs maybe 3 minutes to find them. They decide to continue the mission. Abitar spots the drone swarm and opens fire, tracers arcing through the morning air. The formation splits instantly: 4 high, 4 low, 4 straight through the middle. Machine gun rounds zip through empty sky. But here is what the Russians can't see. Each drone trails a fiber optic cable thinner than a fishing line, while Russian jamming floods every frequency with 10 cows of interference. These cables carry data at light speed, completely immune. The $10 million electronic warfare vehicle below them might as well be a very expensive paperweight. While the drones press on, Russian artillery hammers the operator's position. The Ukrainians had prepared for this. They positioned themselves in 3 separate bunkers, spaced 500 meters apart. And here's why that distance mattered. A 152mm artillery shell creates a lethal radius out to 300 meters. At 500 meter spacing, even a direct hit on one bunker wouldn't affect the others. The Russians could eliminate one bunker, maybe 2 with incredible luck, but never all 3. 8 drones would always survive to complete the mission. The second round lands 600 meters away, closer but still searching. Through the lead drone's camera, the operator can now see the target clearly: black diesel smoke rising from the train. It is approaching a stretch where the track runs straight for 2 kilometers through open terrain, too far from defensive strongpoints, too exposed for close protection to matter. The Ukrainians had studied this route for weeks. The window will last exactly 97 seconds. The third round impacts 450 meters away, and this one changes everything. Shrapnel whizzes through the air at 1,500 meters per second. 3 pieces find their marks: the fiber optic cables of drones 2, 5, and 8. The cables, only 8 millimeters thick, sever instantly. Those 3 drones immediately switch to backup battery power and radio control, but that makes them vulnerable to jamming. The other 9 drones, their fiber optic cables intact, continue transmitting data through pulses of light racing through glass at 200,000 kilometers per second. The operators in Bunker 1 call, continue the mission while relocating. They grab equipment and move to the backup position. The 4th artillery round slams into the ground just meters away, but they are already gone, sprinting through the connecting tunnel to Bunker 4, 700 meters to the east. The artillery would have to reacquire, and that would take time they don't have. Though 3 drones are now on radio backup, the 9 still connected by fiber optic cable are completely immune to the electronic warfare. Radio signals travel through air and can be disrupted by flooding those frequencies with noise. But fiber optic cables transmit data as light bouncing through glass fibers. Jamming radio waves to stop a fiber optic signal is like trying to stop someone's flashlight by shouting at it. The physics simply don't interact. The 3 drones on radio backup face their first real test. The R330Z HZAL electronic warfare vehicle, positioned at the rail junction, detects the swarm at 7 kilometers and immediately activates its transmitters. 10 cows of electromagnetic energy flood every frequency from 100 megahertz to 2 gigahertz. Enough power to overwhelm every commercial drone control channel, GPS signal, and radio communication within 30 kilometers. The 3 drones running on radio control go dark instantly. Their screens turn to static. But the other 9 keep coming. Inside the Zytel's command cabin, the operator watches his waterfall display change as the system pumps out even more energy. Every frequency saturates with jamming. He'd successfully created an electromagnetic bubble 30 kilometers wide. On his scope, 3 drone signals winked out instantly, but 9 others keep coming, their signals impossibly clean. He checks his equipment, confused. How are they still transmitting through 10 kilowatts of jamming? The operators try switching frequencies: 2.4 gigahertz to 5.8 gigahertz and every known military band. Soon, the Zytel broadcast noise across the entire spectrum. It's like trying to have a conversation in a room where 1,000 speakers play different songs at maximum volume. The 3 radio drones fly blind, continuing on their last heading until their batteries die or they hit something. Here's the beautiful irony of electronic warfare. It's indiscriminate. The Zytel's massive jamming field doesn't just affect Ukrainian systems. The BTR-82A crew at Checkpoint 9 can see the swarm approaching on thermal imaging and try to radio a warning to the Panzer air defense system 3 kilometers away. But nothing comes through but static. Their military radios are just as dead as the Ukrainian frequencies. The 9 drones with intact fiber optic cables fly on completely unaffected. The Zytel could pump out 100 cows and it wouldn't matter. The $10 million electronic warfare vehicle designed to knock NATO drones out of the sky at 30 kilometers is absolutely powerless against drones connected by what is essentially very long fishing line. The train engineer warned about possible drone activity during his mission briefing and pushed the throttles forward. The convoy accelerates from 42 to 48 kilometers per hour, then 52, finally maxing at 56, the absolute limit for 4,000 tons of cargo on aging track. But acceleration creates a new problem. Every kilometer per hour faster shifts the intercept point 17 meters further down the track. The Ukrainian operators must recalculate continuously, each course correction burning battery power they can't afford to spare. Checkpoint 9 has exactly 8 seconds to engage. That's how long the drone swarm remains in their engagement envelope as it crosses perpendicular to their position. The gunner traverses his turret, calculating lead for targets moving at 27 meters per second. At that speed and angle, he must aim 15 meters ahead of where the drones are. He opens fire with the PKT machine gun, 800 rounds per minute, arcing through the afternoon air. By the time he calculates the proper lead and walks his fire onto the flight path, the swarm has passed behind a tree line. 8 seconds to acquire, track, lead, and engage 9 targets the size of dinner plates, moving faster than highway traffic. The geometry is impossible. Every round misses. Through his sight picture, the BTR gunner can see the fiber optic cables trailing behind the drones, glinting in the sun like spider silk. He tries to lead them properly, but it is like trying to shoot the shadow of a bird. The BTR commander pounds his fist on the turret. He can't even report the miss. The radios are still jammed. The 9 surviving drones press on toward the train, now 4.2 kilometers from intercept. But the Panzer S1 at the rail junction detects them on thermal imaging. Its radar, designed to track cruise missiles, filters out the tiny drone signatures as ground clutter. The operator switches to electro-optical mode, manually tracking the incoming swarm through what is essentially a very expensive telescope with guns attached. The Panzer proves that sometimes one lucky shot is all that's needed. The Panzer's twin Tu-38M autocannons open fire at 3,200 meters. But the gunner isn't trying to hit individual drones. That would be like trying to shoot mosquitoes with a rifle. Instead, he sets his 30mm shells for airburst detonation. Each round is programmed to explode at a preset distance, fragmenting into 400 pieces of steel shrapnel in a 4-meter sphere. At 5,000 rounds per minute, he creates a wall of metal between the drones and their target. Drone 6 vanishes in an orange fireball at 2,900 meters. 3 seconds later, Drone 11 explodes. The 7 surviving drones immediately scatter in 3 dimensions, 3 climbing to 200 meters, 3 diving to grass height, 1 maintaining altitude but jinking laterally. The Panzer gunner must choose. The Panzer was designed to stop Tomahawk cruise missiles and F-16 SOAM, threats that behave predictably. These drones move like angry wasps. His computer recommends engaging the high group. His training says, engage the closest threat first. He has 2 seconds to decide. He chooses the high group, unwittingly repeating the mistake that cost another train 3 weeks before. He elevates his barrels toward the climbing drones, committing to that target set. Classic air defense mistake. Engage the closest threat first because it has the least time to react. While the Panzer tracks upward, the low-altitude group accelerates toward the train, unbothered. This isn't the only wall of lead the drones must fly through. As they close on the tracks, a platoon of Russian soldiers at Observation Post 7 adds their firepower. 40 AKs firing in synchronized bursts. Hitting the drones is near impossible. The drones cross perpendicular to the soldiers' position at 27 meters per second. At 200 meters distance, Each drone spends exactly 0.74 seconds in a soldier's sight picture. Human reaction time is 0.25 seconds. Target acquisition and aiming take another 0.5 seconds. By the time a soldier squeezes the trigger, the drone is already gone. Meanwhile, 4 special drones at 500 meters altitude dive toward the railroad tracks, 800 meters behind the speeding train, and release their payloads simultaneously. Thermite charges that ignite on impact with the rails. Thermite isn't an explosive. It's aluminum powder mixed with iron oxide that burns at 2,500 degrees Celsius. Railroad steel melts at 1,370 degrees Celsius. The thermite eats through the rails like acid through paper, transforming 4 sections of track into puddles of molten metal within seconds. As the drones continue their approach, the Panzer's barrels glow cherry red from sustained fire. Modern autocannons can maintain maximum rate for approximately 45 seconds before heat warps the rifling. After that, rounds tumble instead of spinning, and accuracy collapses. The gunner must cease fire to cool, creating a 12-second window, an eternity in combat where the sky is clear. 7 drones push through the gap. Battery warnings flash amber on operator screens. The fight against headwinds and constant course corrections has drained power faster than calculated. Drone 3 shows 18%. Drone 7, 21%. They need 30 more seconds to reach the train, but may have only 20 seconds of powered flight remaining. Smoke from thermite-ignited grass fires drifts across the battlefield. Thermal imaging sees through darkness, rain, and fog, but not through smoke. Carbon particles absorb infrared across all wavelengths. For crucial seconds, every Russian defense position loses visual contact. The drones punch through the smoke at 1,400 meters from target. Their cameras show individual details on train cars, unit markings, rust patterns, even the white stencil warning on Wagon 22, Class 1.1 explosive. The fiber optic cables approach maximum extension. At exactly 12,000 meters, they release automatically to prevent tangling. 10 seconds to release. 5, 3, 2. The first cable releases 13 meters short on a simple spring-loaded mechanism originally designed for fishing reels. Drone 1 transitions to battery power, now 8% remaining, enough for maybe 18 seconds if everything works perfectly. The other cables release in sequence over 3 seconds. Drones now fly free, no longer immune to jamming, but also too close to stop. 153 meters from impact, closing at 27 meters per second. The train engineer sees 7 black dots growing rapidly against the afternoon sky through his windscreen. He slams the throttle forward past mechanical stops, overriding every safety governor. The diesel engine's redline, but pushing harder makes things worse. The driving wheels lose traction and begin spinning. Steel on steel has a static friction coefficient of 0.78. Once wheels slip, it drops to 0.25. The harder he pushes, the more the wheels polish the rails instead of gripping them. The train actually loses 2 kilometers per hour, but he keeps going. The Panzer tries one final engagement, but the drones have entered its minimum range, 500 meters, where the autocannons can't depress below -5 degrees. The system was designed to engage cruise missile aircraft in aircraft approaching from above, not ground-skimming drones. $20 million of air defense tech defeated by basic trigonometry. The gunner watches his screen as 7 drones disappear below his engagement envelope. Russian soldiers at the final checkpoint open fire with everything they have: machine guns, AKS, even RPG-7s detonating as improvised flak. But the drones followed the exact center line of the railroad tracks, using the 600-meter train as cover from lateral fire. To hit the drones, the soldiers would have to shoot through their own train. The geometry protects the attackers perfectly. Drone 3's battery dies at 100 meters from target. The motor stops instantly. Props windmill uselessly, but momentum carries the drone forward. At 97 kilometers per hour with minimal air resistance, the dead drone glides the rest of the way. The operator calculated this perfectly. Physics do the rest. Through the last working camera, the operator watches Russian combat engineers attempting to decouple Wagon 22 while the train is moving. The coupling is under 4,000 tons of tension at 56 kilometers per hour. The safety mechanism is designed to never release under load, preventing catastrophic separation during normal operation. The engineers might as well be trying to untie a knot made of steel while being pulled by bulldozers. Drone 9 catches a lucky burst from a PKM, Shrapnel clips its battery pack and it tumbles into the wheat field 400 meters short. 6 drones remain. The operators had calculated for 60% losses from the start. They only needed 4 hits to achieve mission success. The margin is still positive. At 13:59, the lead drone slams into the coupling between locomotive and first wagon. The RPG-7 warhead detonates on impact, shaped charge creating a jet of molten copper at 2,800 meters per second, 9 times the speed of sound. The massive steel coupling pin shears instantly. 4 more impacts follow in precise sequence. Wagon 3's fuel valve assembly ruptures, spraying pressurized diesel. Wagon 7's brake line severs, locking every trailing wagon's wheels. Wagon 18's thin-skinned ammunition car takes a direct hit, starting chain secondary explosions. Wagon 22's ventilation system is penetrated at 13:51 and 18 seconds. Inside Wagon 22, 12 tons of TOSS-1A thermobaric rockets had been slowly heating from vibration-damaged seals. The warhead impact pushes the internal temperature past 447 degrees Celsius, the auto-ignition point. The fuel-air mixture detonates with a pressure wave propagating at 3,000 meters per second. Wagons 20 through 24 simply cease to exist, vaporized into plasma. The blast wave lifts wagons 25 through 47 completely off the rails, flipping them end over end across the countryside. The mushroom cloud climbs to 1,400 meters. In 4 seconds, $4,800 worth of modified racing drones erased $127 million in Russian military assets and severed the only rail line feeding 3 mechanized divisions preparing for tomorrow's assault. Bye for now.